Okay, my algebros, here we go with our last study guide before the finals, right? Chapter 9, study guide, solutions. So let's just go through this one concept that I see has been an error in some of our thinking, right? That's quite a long time ago. So a greatest common factor versus a lowest common denominator. A denominator is the lower part of a fraction, right? So if I'm given numbers and I'm asked what the greatest common factor, well, I factor it out to see what is the greatest numbers that they have in common. And I can see they both have a 3 and they both have 2a. So I would say the GCF is 3a squared, right? So if I were to factor something off of these, it would be 3a squared, right? But a lowest common denominator, you also use factors, but you do this to see what each one is missing, right? So they both have 3a squared in common, right? But in order to be a common factor, 6 needs to have a multiplied by a 3, and it's missing an a, right? And then 9 is missing a 2. So then when we multiply these out, we can see that it is 18a to the third would be the lowest common denominator if these were fractions, right? Okay, hopefully that helped a little bit in some of our situations that we have today. Number 1, it says divide the following polynomials. And 1 through 4, they're just making sure that you understand that every division problem is actually a fraction, right? So we could keep, change, flip, and then we just need to rewrite them in fraction form. Now, if we can simplify, we should. And I factor out a GCF to see if they have anything that they can reduce by. And it turns out that the denominator is also the greatest common factor in the top polynomial. So they can cancel out, and my answer is just 2y squared minus 3y plus 4. Number 2, when I write this as a fraction, I see that in order to factor my top number, my numerator, I must use the factoring of a 3 term that has a value. So I have to AC method. So numbers that multiply to be 2 times negative 12, negative 24, and add to be negative 5 are going to be negative 8 and positive 3. And then I have to factor by grouping, right? Back in chapter 7, I put down the a value, 2m squared. I put down the c value, negative 12. And what makes up that middle term is the negative 8 plus 3. And then I factor by grouping, taking out a greatest common factor, and then regrouping, right? And this is now the top value of that fraction all over 2m plus 3. And we see that the numerator and one of the factors for the numerator and the denominator are the same. So we just end up with m minus 4. Okay, and number 3, I write it in fraction form, first putting it in standard form, which is x squared plus 9x plus 6 all over x plus 6. And I kind of mental map this and see that if I x boxed it, there are not 2 terms that multiply to be 6 that add to be 9. So it's not factorable, so I know I'm done, right? Number 4 is similar in that I divide here, and then I see that it's also not factorable. Okay, on to number 5. So now we are simplifying this rational expression. 1 through 4, we created rational expressions, which are just division problems, and now we are simplifying. And we do this by factoring first. So I xbox the bottom term, 2 numbers that multiply to be negative 12 and add to be negative 1 would be negative 4 and positive 3, right? And when I factor this out, I see that the denominator and numerator can cancel out. I just have to hold that place, though, of the 1 still above. So it's 1 over h minus 4. Number 6, I see the top is a difference of 2 squares, right? Both of these are specials. We have a difference of 2 squares, and the bottom is actually a perfect trinomial. If I can't see that, I can xbox it and see that 2 terms that multiply to be 64 and add to be negative 16 are going to be negative 8 and negative 8. So we go ahead and cancel that out, and our final answer is y plus 8 and y minus 8. Number 7, I'm going to go ahead and solve this by factoring, right? So I have 5, and then I have 2 times 2 times 2 times 6, w to the 6th power. And then 4 is 2 times 2 times w to the 5th power. And I just eliminate the two values that are same, and I multiply straight across. I find that this is the least amount of errors. And then I play the who wins game with my exponents, and I can see that w to the 6th power wins by 1. Okay, number 8, I factor first. And I take a GCF out of the binomials. And when I do this, I can see, and then the bottom term is going to be a difference of 2 squares. And you can really see with all of this, the more I knew chapter 7 with how to factor, the faster this goes for us, right? That's how it is with math. The skills always repeat. Now it gets a little tricky. I can choose to go ahead and reduce now. 2 into negative 2 gives me negative 1, and 2 into 4 gives me 2, and the y's cancel each other out. So we get 2 over negative 1 times y plus 2. You could also have just left it as negative in front of that. Number 9, I'm going to go ahead and change, flip when I divide. I keep the first, I change the sign to multiplying, and I flip the second. Right, so I'm going to factor when I keep the first. Two numbers that multiply to be 10 and add to be negative 7 are negative 5 and negative 2. Right? And then any number can be written over 1 to become a fraction, so I flip that, putting 1 over n minus 5. I get to cancel out and multiply straight across, and we're good to go. Oh, I noticed that I didn't put a multiplication symbol right there. Okay. So again, I keep, change, flip on number 10. I have an X box at the top. Two numbers that multiply to be negative 10 and add to be 3 are a plus 5 and a minus 2. Two numbers that multiply to be negative 7 and add to be 6 are going to be positive 7 and negative 1. I change the sign to multiplying, and multiplying, I see I didn't put that in there. Oops. And then I don't want to do another AC method if I can avoid it. So when I'm flipping this over and going to factor it, I see I can take out a GCF by dividing by 3, which leaves me with a squared plus 6a minus 7. But I just factored that before, right? So I know I have the same factors for that, which are a plus 7 and a minus 1. Then I take a GCF out after I flip the second part, which is 9a squared, leaving me a minus 2. Go ahead and cancel things out and multiply straight across. And I know I talk pretty quickly on these videos because I don't want to have to take super long to upload it, but just slow it down, do it at half speed, or pause a lot, all right? Now on here, this only asking you for the lowest common denominator. Notice it's not giving you an operation. It gives you this comma because they want to know between 15 v to the second and 20 v to the third, what would be the common denominator for this? So I factored them out first, and I see which each one's missing. So they the 15 needs one more v, and it needs 2 more 2's, right? And 20 just needs a 3. And when I multiply all that out, 2 times 2, 4 times 3 is 12, and 12 times 5 is 60v to the third power, which is going to be our common denominator here. Whoop, it's getting ahead of myself on this one. So on the next one, I'm going to go ahead and factor first, right? So I factor the first term out. Two numbers that multiply to be 7 and add to be 8 are going to be 7 and 1. And on the second one, two numbers that multiply to be negative 3 and add to be negative 2 are going to be 1 and negative 3, right? Which shows me that they both have a u plus 1 in common. So that's one of our factors already. And then the first term is going to miss the u minus 3, and the second term is going to miss the u plus 7. So this makes up our lowest common denominator, what they would all need to have. Now let's see what it's like if we add or subtract after we get our common denominators, right? So First, does it have a lowest common denominator? And number 13, it does have a lowest common denominator. So now I just get to add or subtract. So on here, my common denominator is 5x minus 3. And it says that we're going to take x plus 13 and we're going to subtract 9x. And we're going to subtract a negative 20, which means we add it, right? And now we simply combine our like terms. That's what it's like to add and subtract polynomials. So we have negative x, 9x, and an x gives us negative 8x, and 13 plus 20 is 33, all over 5x minus 3. And I cannot simplify here. There's nothing to factor out to reduce, so I'm done. Number 9, we kind of looked at this one before. We factored these out, and we can see which each one is missing. We know the greatest common factor is going to be 18a to the third, but that means on the first term, it's missing a 3a squared, so I have to multiply the top by 3a squared. On the second one, it's missing a 2, so I need to multiply the numerator by 2. And now I can finally multiply it out and combine my like terms. And there's nothing to combine here, so I am done. On 15, I'm just going to give myself a little room here. The first fraction, these are already factored out, right? So I know that the first term is missing x plus 3, and I have to do that to the top as well. And the second is missing x minus 4. Now I need to distribute with the first, and then I'm subtracting again. So I'm going to make this an addition by adding the negative to the 5 instead, right? So negative 5, and I distributed that, and now I combine my like terms, and this cannot be factored, so I am done. So number 16, I go ahead and factor first, and I see a difference of 2 squares on one side, and c minus 1, and c minus 6 on the other. So I know that on the first term, it's missing a c minus 6, and on the second, it's missing a c plus 1. And whatever I give to the bottom, I have to give to the top. So I go ahead and distribute. And then I see that's a subtraction problem, so I got to give that negative 3 to the 3 and distribute a negative 3, getting negative 3c minus 3. Now I combine my like terms, and gratefully I do not have to factor this using AC method because it's not factorable. All right, how do I do things that are equal fractions? Well, I could get a common denominator, or I could just do cross products with this. This is actually a chapter 1 question, right? We know that it says that they're equivalent fractions, so our cross products are always are going to be equal to each other. So I distribute a 4 to x plus 1, I distribute a 7 to x plus 4, and I just solve for x. And I'll get negative 8. And I could put that in to see if it would make sense. But you can see that it would make sense because 7 over negative 8 plus 1 would be 7 over negative 7, which is negative 1, right? And if you put negative 8 into the other equation, I'll have 1 over negative 8 minus, 4 over negative 8 minus 4, which would be 4 over negative 4, which is negative 1. Negative 1 equals negative 1, so we know we're right. On number 18, I'm going to go ahead and get a common denominator for everybody. So the x minus 1 has to be multiplied by the 3, and the 3 has to be multiplied by x minus 1. Now here's a really fun thing. Once we have got this common denominator, we actually can just get rid of the denominator, right? Because we can, we know they are the same. So we can just solve for the top when we're solving for x. So on here I have combined my like terms, and I solve for x, and I get 4. Now this process of being able to cross out a common denominator once you've solved to get a common denominator really helps us with the next phase of these word problems, right? So you can weed your neighbor's garden in 3 hours, and working for your brother, you can complete the same job in 2 hours. What would your brother's rate be, right? It seems like he's been awfully helpful, but let's see if he really is helpful or not. So let's see, you can do your job, one job in 3 hours, right? Your brother Does it? And we don't know. We're going to find out, right? But we know that you and your brother are one job in 2 hours, correct? So we know we can solve this by saying that you plus your brother equals 1/2, right? We're going to go ahead and just solve for x temporarily. And so we have these fractions, 1/2 minus 1/3. So I have to get a common denominator, and I get 1/6. So now I have that 1 over x is equal to 1/6. I can flip these over and then get rid of my denominator. And I have solved that your brother is going to take 6 hours if he goes on his own. So he actually takes twice as long as you do. So is he helpful? Well, a little bit, right? Okay, maybe it's your little brother. So, number 20, you and a friend share responsibilities of delivering newspapers. Again, we have jobs over hours, right? And your job takes you 2 hours, and your friend, it takes them 3 hours, right? We want to know how long would it take if you guys got to work together, right? With this job over hours, we want to go ahead and get a common denominator. So we can go ahead and just kind of get rid of that. Okay. And when I do that, now my denominator is all 6. So I can just look at the top terms. So I have 3j plus 2j equals 6. And, sorry, it's writing so quickly. Got to put my stop signs in. When I combine those like terms, 3 plus 2 is 5. So when I divide this off, your one job is going to take you 1 and a 5th hours, right? But how long is that actually? So 1 and a 5th, that we know 1 hour is 60 minutes, right? And a 5th of an hour is 12 minutes. So together you take 72 minutes. 72 minutes, right? That's helpful. Okay, do great. And we will see you on the test day. So I think what I'm going to do, if you want to use your study guide on this last test, you can. But the word problems will count as part of your grade. If you choose not to use your study guide and do it without your study guide, then the word problems will be extra credit. All right, have a great day, and I will see you tomorrow.